Hi guys, so today we're going to be moving into chapter 7. Before I get started with the lesson, please make sure you complete the entrance ticket by 12 p.m. tomorrow, which is Friday, unless you're watching it today. So, with chapter 7, we're going to take what we did with solving for area and apply that one step further because this chapter is going to focus on surface area and volume. So we're going to get started today with just the first part, and that's three-dimensional figures. So up until now, you've just been working with two-dimensional figures. So at the conclusion of the lesson, there's going to be an assignment for you guys to complete and make sure that you submit it on Schoology. 1, 2, 4. So, like I said, we're going to focus today on three-dimensional figures. So what you guys are going to be able to do is classify and draw three-dimensional figures. Now remember guys, your guided note sheet is posted on Schoology for you guys to follow along with. So first and foremost, what is a three-dimensional figure? It can be solid. And then a three-dimensional figure is a figure that does not lie in a plane. And we use 3D to simplify. You guys probably are used to seeing 3D, especially when it comes time to talking about movies and anything like that. But a three-dimensional object is how we use 3D for. Now, parts of a three-dimensional figure, there's a few different parts. So a face is a flat surface of the shape. So in this case, this rectangle right here would be considered a face, okay? And you guys should label the figure too in your notes, but it's a flat surface of a solid shape. Now you have edges. Edges are a segment formed by intersecting of two faces. So what that means is these solid dark lines here, they're the edges. So even if it's the one down the side, okay, they're considered edges. Bases are congruent, parallel, polygon faces. So there's just two of these here. So they have to be a polygon. Now, a polygon is any closed figure. Okay. So any shape is technically considered a polygon as long as it's fully closed. That means that if you were given something like that, that would not be considered a polygon because it's not closed. Now, if I connect these parts right here, that makes it a polygon because it's a closed plane figure. One thing for you to note is that not all figures will have two bases. Okay, sometimes it could be where there's just going to be one base. It's kind of all going to depend on what the figure is. Now, a vertex is the point where the faces come together. So what that means is it's going to be that point right there. Again, it could be this point here. It could even be this point where you have this dotted line. Just one thing for you guys to know is that those dotted lines represent that it's technically a line on the shape, but if I were just looking at the figure like straight on like this, you technically wouldn't see it if it was fully solid, okay? So those represent that there's lines in the figure. It's just that if you were looking at it straight on, you wouldn't see them. And then like what we talked about before with parallelograms and trapezoids, the height is the length of a perpendicular segment that joins the bases. So the height is the length of a perpendicular segment that joins the bases. So we're going to get into a few different three-dimensional figures. The first one that we're going to talk about is a prism. So a prism is a 3D figure with two parallel, congruent polygon faces or bases, okay? So it's two parallel and congruent. Remember, congruent means equal. And parallel means never intersecting. Okay, so they're never going to intersect and they're going to be equal. The height of a prism is the length of a perpendicular segment that joins the bases. So that could simply mean it could simply be this segment right here. Okay, because so you know this right here would be a base, that rectangle. okay? And it's named for the shape of its bases. So in this case, it would be called a rectangular prism, okay, because it's named for the base. Now you have a cube. A cube is known as a rectangular prism, but because all the faces are squares, we call them cubes. You guys are used to seeing cubes, especially if you play with dice or anything like that. The next one is a cylinder. A cylinder has two congruent parallel bases that are circles. And the height is the length of a perpendicular segment that joins your bases. Okay, so the height is the length of a perpendicular segment that joins the bases. Sometimes you might see your height drawn in like this. Okay, with that segment coming straight down, and you might see the little square like that. So you could also see your height like that. With a cylinder, your bases are circles. So you have these two circles. You have this top one here, and you have the bottom one. Okay, meaning you're going to need to make sure you know how to find the area of a circle in this case. And then you guys are used to seeing cylinders if you use canned veggies, canned fruit, soup, anything like that. So cylinders are something you guys see around your houses. A pyramid. So a pyramid has triangular faces that meet at a vertex, so that meet at one point. And these are considered the faces. Now, your base is a polygon, and it's named for the shape of its base. Okay, so your base is a polygon, it's named for the shape. So in this case, looking at my base, it looks like it's a rectangle. So in this case, I could call this a rectangular pyramid. Okay, so you always name a pyramid based on its base. Okay, not on the faces, it's named based on the base. So the next shape we're going to talk about is a cone. A cone has one circular base, so you have this circular base at the bottom, and then you have a vertex, okay, so 1 point. And more commonly, guys, you guys know a cone as that wonderful treat that you guys all have in the summertime. I'm not the artist, remember that's Miss Luby, but you guys all know a cone for ice cream this time of the year. Miss Luby, where you at, girl? I need your artistic abilities. So we have mint chocolate chip. We don't really have any other colors. So we'll put a little bit of yellow, okay? But gives you the picture of what a cone is. One more shape for us to talk about is a sphere. It's a set of all points in space that are in the same distance from the center. So if you have a center, which is right in there, all distances on either part, so either it's going to be this outer or the inner part, they're all the same distance from that center. Okay, even if you have points on this back side here, they're all the same distance from the center. Okay, and a sphere, guys, you could think of it as a ball. So, naming figures. So what we're going to do is we're going to look at some images and we're going to name each figure. And we're going to use the 3-dimension. So looking at this first one here, a Rubik's Cube, something I can't solve. If I notice, I have 3 by 3. And then on that side it's 3 by 3, and on the top it's 3 by 3. So I have the same dimensions on all of my sides, which tells me this one is going to be a cube. Now I have this drum looking here. So if I look at the drum to start out with, you guys have these bases here. Okay, so I have one on the front and I'm going to have one on the back. So if I were to turn this, and then my bases would be on the bottom, if I just draw it out for you. Some of you guys might already know what the image is. But if I draw it out for some of us, that image then is a cylinder. Okay, so this would be considered a cylinder. So that's naming the figures. Now I want for you guys to try yourself. So pause the video right now and try naming this hat with some stars and then the fruit of an orange. So pause the video. Alright, so here's your answers. The first one there is a cone, and then the second one is a sphere. So for this next part, if you have graphing paper, that would help. If you print out the notes, I did give you this. Another thing you're going to need is a ruler. Okay, and I do put the little note here, use dash lines for hidden edges. So what we're going to do first is we're going to draw a rectangular prism. So what I'm going to first start out doing is drawing a rectangle. So remember, with a rectangle, your length and width aren't the same. So I'm just going to pick any size rectangle to draw. So if I notice I have a 1, 2, 3, 4. So I have a 4 by 1, 2, 3, 4, 5, 6 by 6. Okay, so I have a 4 by 6 here, rectangle. So first I draw a rectangle. Now I'm going to draw a rectangle congruent to the first one, but just offset. So when I say offset, I mean I'm just going to have it shifted a little bit. It could be 1, it could be 2 units, it doesn't matter. So I'm just going to shift it over like 3 units. So remember, I have a 4 by 6. I'm just going to draw myself another rectangle. Okay, they're offset now. Now I'm going to connect my vertices, and then I'm going to have to remember to use dashed lines when drawing hidden edges. So if I'm looking at this right on, this line here I can clearly see, and this line here I'm clearly going to be able to see. Now this back edge right here, so this one on my figure, that one I can't clearly see typically. So what I'm going to do is I'm going to fix that so then it's dotted. Okay. And then the same thing goes with this side right here. Okay, that's not one you can normally see, so I'm going to also fix that one to be a dotted one. And you guys can always fix them too after you get the image in. Because now, going from this vertice to this vertice, that one I should have a dotted line as well, because that one's hidden. And then the top, you can connect. Alright guys, so there it is, a rectangular prism. So what's really important here is when you're drawing these is to first draw the bases and then offset one of them. Okay, so first draw one of the bases and then offset the second one, and then just connect your vertices. Okay, so I want you guys to try drawing a triangular prism. So pause the video right now and try drawing a triangular prism. Remember, your figures are named based on the base. Okay, so remember, it's named based on the base. Now, I used the graphing paper back here, but if you look down here, there's my triangular prism. So I have 2 triangles, and then I connected my lines using connected my vertices using lines, and then this one right here ends up being dotted because I typically wouldn't be able to see it. Okay, so now that we are finished the lesson, you guys need to complete page 254, number 7 to 19, odd from your textbook. Now, I know many of you probably don't have your textbooks because they're all sitting in your locker. So I have taken a copy of the textbook page for you guys and have uploaded it on Schoology. There is a submission box, so what I want you guys to do is complete the questions and then open up the Schoology submission. Now, guys, for those of you that haven't been paying attention, a lot of your worksheets and textbook work I have been giving you guys 2 attempts at, and some of you have been taking advantage of it, but not all of you. Okay? So I suggest you guys start to take advantage of those. But other than that, this work is due Friday at 11:59. And just so you guys are aware, I know I posted it on Schoology, but no new work will be pushed out until next Thursday, okay? Because Monday's Memorial Day. So I won't be pushing out any work until Thursday. I hope you all have a wonderful weekend. Stay safe. Enjoy it. Have a great weekend, guys.